Good evening and welcome to this evening's webinar, Plant Sap Analysis, Emerging Technology and the Competitive Advantage for Consultants. I'm Michelle Gregg, Executive Director of Crop Health Labs, and on behalf of the staff and supporters of the laboratory, we are pleased to have you as our guests as we gain valuable insights on plant sap analysis as an emerging technology in North America. Our featured speaker this evening is John Kempf, founder and CEO of Advancing Eco-Agriculture, as he details the ways sap analysis has enhanced his company's ability to better manage crop fertility and enhance his clients' nutrient success. Crop Health Laboratories is the exclusive distributor of plant sap analysis in the United States, a technology that was founded by Sjoerd Smits and Bart Vromans of Nova Crop Control in the Netherlands. John Kempf is a founding member of Crop Health Laboratories, and it is largely because of his passion to empower growers with empirical and reliable data that sap analysis is available to any grower in the United States. Crop Health Labs is currently located in Central Ohio and coordinating all shipments from North America to the laboratory. We are also working to construct an identical laboratory here stateside in the coming months. This evening's webinar is being recorded and will be available on our website, crophealthlabs.com, by Friday of this week. If you have questions of John or the technology, please reference the Questions tab in your control panel on your screen during the webinar. Attendees will receive an exclusive offer for SAP analysis following this evening's webinar by email. We encourage you to ask questions, and I will be monitoring all questions as John speaks and relaying to them during the presentation. John, welcome this evening.
Good evening, Michelle. Thank you. Good evening, everyone. I would like to thank Michelle for the introduction, for the opportunity to be here. We've had an interesting growing season so far this year with Advancing Eco-Agriculture and a farm that I run and manage personally here in Northeast Ohio with severe wet weather that we would be happy to share with people on the West Coast. Michelle asked me to talk about a number of different pieces tonight, and in essence, I wanted to really share the story of the consulting work that we have done at Advancing Eco-Agriculture over the course of the last half a dozen years or more, how that has evolved since we have started using SAP analysis, and the benefits that we have been able to achieve as a consulting company, and the benefits that our customers have achieved as well with since we have started using SAP analysis as a management tool in the field. So I have an outline of some of the things that I want to talk about, but this is very open, interactive. If at any moment you have questions, feel free to ask them, and Michelle will relay them to me right away, and we'll flow through this very smoothly. So the pieces that I wanted to talk about this afternoon, we have been using, as a consulting company at Advancing Eco-Agriculture, we have been using SAP analysis now for 3 years. Actually, this is the third growing season that we've been using it. And we have learned a lot of things. We've learned things about crops that we did not know. We've learned things about nutrient interactions. It's been a very intense learning experience, and it's been a very enjoyable experience as well, because we have been able to help farmers, and we've been able to come up with solutions for challenges that we didn't understand before. And so it's been a lot of fun. I've really enjoyed it, and our entire team has enjoyed it as well. So I want to describe kind of some of the background and the history of our consulting work, and then to really be able to describe the benefits. I could go through and kind of give you a list of bullet points of some of the benefits that we have realized, but I think it'll be the most powerful if I'm able to share several stories with you of actual in-field experiences that we have had, and data that we were able to look at, what we learned as a result of that data, and the benefits that the farmer realized and the benefits that we realized as a consulting company. So one more thing, and so I have a couple of those stories that I want to share, and then I want to follow up with some of the some additional points of things that we have experienced that may not necessarily be illustrated by those stories. And I'm going to try to review this in 35 to 40 minutes or so, and then open it wide open for questions and answers as well. One of the things that I'd like to mention before we really get into this is I was one of the I really badly wanted a tool that was much more accurate than the tools that we had available at the moment or 3 years ago to analyze plants in the field, and I was really motivated to bring SAP analysis here into the United States. I'm one of the founding members of Crop Health Laboratories. With that being said, we value the confidentiality of customer data within Crop Health Laboratories, and as I am also a consultant doing consulting work, your data as a Crop Health Labs customer is completely confidential. I do not have access to it, and I do not look at it without your approval or your request even. So any company would be able to run samples, or any consultant would be able to run analysis through Crop Health Labs, and I do not have access to that data without your authorization. So I wanted to point that out as well, just for to maintain confidentiality. So our consulting work with Advancing Eco-Agriculture, I founded Advancing Eco-Agriculture in 2006 as a consulting company, working with fruit and vegetable growers mostly throughout the United States, also some work in Canada, but pretty much all within North America. And we've also done some work on broadacre crops. In 2009 and 10 and 11, for a 3-year period, we did a lot of testing with product evaluation and began developing our own products as well. But for the purposes of this discussion, what is really relevant, we've been doing consulting work for about a 6-year period, and we had on fruit and vegetable crops before we started working. Maybe it was longer than 6 years, but we had a variety of challenges with the tissue analysis that we were using at the moment that we were very frustrated with. So our frustrations in using dry matter-based tissue analysis, which we were running a lot of samples of on quite a variety of different crops all across the country, we found that the data was inconsistent at different growth stages, different points during the growing season, different fields, different varieties. There was a lot of variability, and there was no correlation to the variability, which was a real challenge for us in making recommendations to growers. And this was, the data inconsistency was specific to a number of different nutrients. Another major frustration was that sometimes plants were showing very obvious visual deficiency symptoms that anyone could see quite readily, and the analysis, the data on the dry matter-based tissue analysis still indicated that the level should have been accurate or within range. And that was a major cause for concern for us as well. We did not feel that we were getting the data quality to be able to make good management decisions. And I would like to point out also, this was a frustration that I shared with many other consultants. It was a topic that we discussed at several different conferences that I attended. I gave several different presentations on it myself. And consistently, whenever I talked to agronomists that had multiple years, quite a few years of experience in the fruit and vegetable world, this was a very common constraint, that the data was not replicable and was not reliable enough and consistent enough. And then lastly, and very important for myself, I had done a lot of research work on plant immune systems and trying to understand how plants can develop functional immune systems and be resistant to diseases, in particular, both fungal and bacterial pathogens. There was a lot of evidence in the scientific literature to correlate specific disease and fungal and bacterial disease profiles with specific nutritional imbalances and specific deficiencies. Yet we were never able to pick that up with the dry matter-based tissue analysis. There was no correlation whatsoever to specific diseases that we were able to determine. So, and I believe that based on all the information that was out there, that should be very possible. It should have been easy for us to predict with the data and the scientific referenced information that is available today, it should be possible for us to predict disease susceptibility based on a nutritional profile the exact same way that we can predict disease of the human body by looking at a blood analysis. And we were unable to do that using tissue analysis, which was quite a disappointment for us. Additional challenges and frustrations were that frequently we would be able to put on nutritional products either in irrigation systems or with foliar sprays, and we got, according to the data, we got no response whatsoever. The needle did not move. And most challenging of all, because we did not have data that we were confident in relying on, it often felt as though we were constantly making reactive decisions rather than proactive decisions. We were constantly responding to crisis, and it was crisis management on the nutrition side and nutritional management side rather than preventing problems from showing up in the first place, which was quite a frustration. So I'd like to share two different stories of kind of to share some of our experiences with what happened with SAP analysis before we started using SAP analysis, and we were using dry matter-based tissue analysis, and then after the fact as well. So the first piece is in Pennsylvania with tomato production. In southeastern Pennsylvania, down into Virginia, we work with several hundred small-scale Amish farmers, many of which have anywhere from 2 to 5 acres of tomatoes, frequently anywhere from 1 to 3 acres of tomatoes in a high tunnel. So we had quite a diversity of different tomato growers in very similar climate and soil conditions. We were able to get reasonable results on the actually quite good results by the usual standards in tomato production with the products that we had been using at that point in dry matter-based tissue analysis, but there was still room for improvement, and we still had several quite significant challenges that we were not able to resolve. So on our tomato production, I just want to give you kind of an agronomic background and overview of what was happening. First of all, they had, from an agronomic and geological perspective, we're talking about a local microclimate that has limestone-based soils, slightly alkaline soil pHs ranging anywhere from 7.2 to 7.5, occasionally higher but not common, and extremely large quantities of available manure, livestock manure, both dairy, cattle, and as well as poultry. So as a result, the soil profile has extremely high levels of calcium, very high levels of phosphorus, very high levels of potassium. Just to give you a reference point, I'm talking about on soil analysis levels, melic-3 extraction, phosphorus levels routinely show up in the neighborhood of 250 to 400 parts per million, and potassium levels routinely show up in the neighborhood of 400 to 700 parts per million, sometimes higher. I've seen them as high as 1,200 to 1,300 parts per million. So we have very high potassium and phosphorus levels and calcium levels in the soil profile, and plants were having difficulty absorbing all three of those, as well as other nutrients as well. Magnesium was correspondingly low in the soil profile. So for tomato production, historically, on these soil types, plants, based on the tissue analysis data, plants were absorbing very low levels and were consistently deficient in potassium and calcium. So we were consistently putting on heavy applications in the drip irrigation system of liquid potassium and calcium on the order of, well, there's obviously different product concentrations, but we'd routinely be putting on 2 to 4 gallons of a liquid potassium and 1 to 2 to 3 gallons of a liquid calcium per acre per week with very bioavailable chelated potassium and calcium sources. So, and even at those levels, we still constantly struggled with deficiencies based on the data that we were getting on tissue analysis. And in addition, we also we're consistently seeing very low levels of manganese showing up in tissue analysis. So our common practice was to put on foliar applications of manganese sulfate, very aggressive applications, usually in the order of 8 ounces to a pound per acre. We would recommend lower levels than that, but the farmers in this region are very intense and they wanted to fix the problem all at once. So they would usually go on with quite a bit heavier applications than we would routinely have recommended. So what was happening here, the tissue analysis results that we would get back with this management paradigm, potassium was consistently low in leaf tissue, and it moved very little or not at all, almost irregardless of the amount of potassium materials that we applied. Manganese levels were always very low in the leaf tissue before we applied the manganese sulfate, and then as soon as we applied the manganese sulfate, the levels would jump quite a bit, and we believed that we had solved our problem. And calcium levels were always very low in the leaf tissue as well. So when we started using Sap analysis 3 years ago, this was one area in which we first began to do some testing to evaluate the technology. And the surprising part was that on tissue analysis, potassium was always showing up as being slightly deficient or barely adequate. And on Sap analysis, potassium levels often showed up as being adequate to generous. And the most fascinating part of all was whenever we put product on, the potassium numbers moved very quickly. We could see that in Sap analysis where we had not been able to see that with tissue analysis. The second interesting observation was that manganese levels also showed up very low in plant sap. And whenever we put on the foliar applications of manganese sulfate, the manganese levels did not move. They remained absolutely untouched. We got no response whatsoever in manganese absorption in the plants from applications of manganese sulfate. And the Sap analysis did correspond very well with the tissue analysis in calcium levels, and that the calcium also showed up consistently very low in the plant sap as well. So, what did we change as a result of that? What we changed is in the first place, because we had adequate potassium levels showing up, we stopped all the potassium applications in the irrigation system. And we switched the foliar applications of manganese from a manganese sulfate to a manganese chelate. And we've done a lot of testing with a variety of different manganese chelates. And in short, I can tell you, obviously we've developed our own product, but in short I can tell you that the organic chelates in our trialing and testing significantly outperformed the synthetic chelates. So what happened, there were some really interesting shifts that happened when we made just these two changes. And so the first thing that happened, and these 3 results that are listed in no particular order, I'll start at the bottom. As manganese levels, when we switched to manganese chelates instead of manganese sulfates, the first thing that happened is the manganese levels went up quickly. The needle moved really fast with the chelates where it did not move with the manganese sulfate. And then, as the manganese levels went up, all of a sudden, potassium levels, in some farms where we had excessive potassium showing up on Sap analysis, the potassium levels dropped. In others, where it was adequate to barely adequate, sometimes bordering on deficient, the potassium levels moved up. We saw both things happening. And it was a really interesting observation, and we've seen this quite a bit in the years since then. But what we have learned is that manganese is a potassium regulator. It's both an upregulator and a downregulator. So in this native soil environment where we had very high potassium levels, when we improved manganese levels, the potassium levels auto-regulated to precisely where the plant needed them to be. It was a very powerful experience. Then, as the potassium levels adjusted, And also, when we stopped the potassium applications, as quickly as we were no longer putting on the heavy potassium applications, all of a sudden the calcium levels in the plant frame, in the leaves, in the sap went up quickly. We were able to see that move as well. And we were able to see that move not only on the sap analysis, but also the visual plant expression itself. The plants began expressing themselves differently, and we could actually see the expression of higher calcium content in the leaf frame, which was very exciting for us because we had not been able to achieve that in the past. And when we started working with Sjoerd from Nova Crop Control in the Netherlands, he described for us the antagonistic relationship that we see in crops between calcium and potassium, and we've now observed that as well ourselves on a variety of different crops. And it became quickly obvious to us that the high levels of potassium that we were applying was resulting in not getting adequate levels of calcium into the plant. So, what we learned, manganese is a potassium regulator, can both upregulate and downregulate potassium, and the excess of potassium reduced calcium absorption. So, the benefits that we realized, the farmers saw, the first thing that happened, because of the higher calcium content in the fruit quality went up very significantly. There was a direct correlation between the higher manganese levels in the sap itself and the resistance to fungal diseases. We particularly noticed increased or reduced incidence of verticillium and fusarium. Both went down significantly. And a really big piece for the farmers was that application of potassium, the fertigation dropped across the board on hundreds of farms by about 65%. So I arrived at that 65% number prior to us using Sap Analysis as a management tool. We were selling liquid potassium to tomato growers in eastern Pennsylvania by the tractor trailer load. Very large quantities. And our sales dropped dramatically, which was a very good thing for the farmers, and in reality it was a good thing for us as well, because that reduced application resulted in the potassium resulted directly in the increased calcium absorption and the better fruit quality and better crops, higher yields, more money for the farmer. It was a significant win all the way around. So yields went up. I do not have data on yields across the entire region, but I do know that yields increased just based on walking the fields and history, being intimately familiar with the history over the course of several years. I would say that on average, yields increased anywhere from 5 to 10% in about a 2-year period, just as a result of farmers making that management shift in understanding potassium and manganese and calcium interactions better. And we had a sharply reduced disease incidence of fungal root diseases. And the fertilizer budgets dropped very sharply. And as a consultant in working with these farmers, I do not talk about reduced input costs or reduced fertilizer costs. What I really care about is making more money per acre. That's what we focus on, the farms that we work with, is we want to increase the money that they make per acre. And in this case, reducing the nutrient applications was just an added bonus and an added benefit for them and for us. So the benefits that we realize as a company, as Advancing Eco-Agriculture, with the use of SAP analysis, as farmers started looking at the data, 2 things happened. First of all, farmers started really loving us. They gained a tremendous amount of confidence in our recommendations when they realized that we would not recommend products just to sell products. When they saw what our shift in position on potassium and the results that they got. Secondly, with the use of SAP analysis, farmers could actually see the data and look at the data, and they could tell. They now had a tool in which they could tell whether products worked or not. They experienced it on the manganese sulfate. They put on manganese sulfate because it's cheap, and nothing happened. they put on a manganese chelate, and they see the numbers triple in the SAP analysis in 7 to 14 days based on the frequency with which they're doing SAP analysis. And all of a sudden, they become really excited because now they can see things happening and they can also see the plant respond. So as a result, the farmer's engagement with nutrition management on the farm went up rapidly. And as that engagement went up, management intensity went up. We were able to manage crops much more carefully, and we were able to make a lot more money for our farmers that we were working with because of that increased management intensity and because of their better engagement with since they now had a tool that they had confidence in and that we had confidence in. It was a really empowering experience for them. So actually, before I continue, I could just go back with this. Michelle, are there any questions so far that would relate to the story on tomatoes in Pennsylvania? None at this point?
Apologies, John, I had to unmute myself. We do have several questions if you have the time to go ahead and take them. One is specific actually to corn, and it pertains to the shift in the nutrients during the life cycle of the corn plant. Do you foresee plant sap analysis being able to be used as an indicator of nutrient deficiency at different stages of the corn plants, or could you detail how you use it at different stages?
Yes, I can. I do think what I would like to do, Michelle, is to answer that question following the next example, which is on cherries, because I will be talking about different stages in cherries, and I think it'll correlate perfectly with that.
Wonderful. The next question is, what do you mean by auto-regulation, and can you give an example of auto-regulation? Your reference was keeping potassium application low. Could you explain it more deeply?
In brief, this also ties in the next example, but very briefly, what we observed is that when plants had adequate levels of physiologically active manganese, and I should go back to this tomato example, I should point out that we would put on manganese applications of manganese sulfate before we were using SAP analysis, and the levels would increase on the tissue analysis. The levels would go up, and we thought that we had fixed the problem. When we started using SAP analysis, we put on applications of manganese sulfate, and there was zero response. So our hypothesis is that the manganese sulfate, and we have learned a lot more about manganese applications and trace mineral applications since then. But what we've learned in essence is that the manganese in manganese sulfate is actually in the incorrect oxidation state and is not available for plants to utilize directly. So you can put on all the manganese sulfate you want to, and you're going to get a very minimal plant response. It will accumulate on the leaf surface, but it will not actually be absorbed by the plant and will not become physiologically active. So when we started applying the manganese chelates, and the manganese levels moved very quickly, the first thing that happened was that there was a visual plant response. You could see that something had changed within that plant structure. So, and I could, in short, one of the significant indicators, the visual indicators of manganese deficiency, when you have a manganese deficient plant, the veins on the leaf are a lighter green color than the leaf itself. That's one of the visual indicators that you can look at for manganese deficiency, and you can see this very obviously on almost all Roundup Ready crops that have had glyphosate applied, because the glyphosate will take the manganese out of the system. So it's quite obvious there, and you can see it on a lot of other crops as well, including, you can see it on weeds, you can see it on almost any plant. So specifically, to come back to answering the question, what we saw as manganese levels went up inside the plant, some fields and some plants had excessive levels of potassium. As manganese levels went up, those excessive levels of potassium went down. And we also saw the exact opposite. Soils or soils that had adequate potassium levels, but plants which were growing on those soils with potassium deficiencies, when we applied the manganese, the potassium levels went up. So when I talk about manganese being a potassium regulator, it is both an up regulator and a down regulator. And it basically, for lack of a better term, it gives the plant a signaling mechanism to indicate whether it has adequate, or to allow it to auto-regulate and balance potassium levels on its own. Michelle, I can hear your keystroke commands or keystrokes in the
I am
background.
so sorry, John.
Just thought I would mention it. So this actually ties in directly to the next story that I wanted to talk about, which is on cherry production in Oregon. So because we had a really interesting experience. Michelle, I apologize. I am not able to look at time. How am I doing on time?
We are at 7:38 currently.
Okay, thank you.
Mm-hmm.
With Oregon, with the cherry production operations that we have worked with in Oregon, we have learned some very interesting things that relate to manganese, potassium, calcium interactions, nutrient interactions in general, and also relate to the different growth stages of a variety of different crops. So I'll talk about this for just a moment. So historically, on cherry production, the nutritional management practices were to apply very aggressive zinc applications. The objective in cherry production, number one, is fruit firmness. Number two is large fruit size. And number three is sweetness. We need those three things in that order of priority. So we were using, farmers were using very aggressive zinc applications to achieve very large leaf sizes and also very large fruit sizes as a result. And then along the same line, applying very aggressive potassium applications beginning at bloom or shortly after bloom to help achieve a very large fruit size. So the tissue analysis results were showing adequate levels of potassium and calcium with this type of management practice, and low to moderate levels of most of the trace minerals such as manganese, copper, boron, and so forth, and quite high levels of zinc as well. When we switched to beginning to use Sap analysis, the Sap analysis results differed quite markedly from the tissue analysis in that they showed very low levels of calcium in the leaves. They showed very high levels of potassium, extremely high levels of zinc, and next to none detect levels of manganese, copper, iron, cobalt, and boron. So we had very low levels of all of those minerals. And this is actually an example, since one point that I would like to mention, within agronomy and agricultural consulting, kind of the reference point from which I was trained and from which many agronomists are trained is that the way to fix problems on farms is we document or we figure out what the deficiencies are, and we put on products to fix the deficiencies. Since we have started using Sap analysis, I would say that on 90% of the crops that we have the opportunity to work with, deficiencies are not the problem. They're actually the problems are the excesses of nutrients that farmers are applying that are creating deficiencies of other elements. So this cherry production operation is a really good example of that, where they were over applying zinc and getting very high level zinc levels to the point where they were excluding manganese and iron and copper and other trace minerals from actually getting into the leaf system. So there are actually excesses that were creating the deficiencies. So what we changed, we completely eliminated the zinc applications. We added applications of all the other trace minerals with a particular emphasis on manganese. We cut all of the potassium applications before fruit fill. And we greatly increased the calcium applications from blossom to the cell expansion period. So to go back to the earlier question about nutrient applications at different stages of plant development, we know that a plant's nutrition requirements change at different stages of fruit fill, fruit development, physiological development throughout any growing season. And I want to be conscious of time and be sensitive of the clock here, but I would like to take just a moment to explain what is happening in cherries, well, for what happens in any reproductive crop for that matter. So from the moment a seed, or from the moment a bud is pollinated, from that pollination period, from the pollination moment to there, for about depending on growing degree days and local climate, there's about a 10 to 14 day period in which you have cell division, where all those cells are simply expanding, dividing, and multiplying very rapidly, and you're building a tremendous cell population. Then at the 10 to 14 day window, or whatever is the appropriate window for the crop that you're talking about, this varies quite a bit, but many crops fall within the 10 to 14 day window, cell division gets completely shut off, and the plant switches to cell, and that embryo switches to cell expansion. So from that point forward, we're simply filling all of those cells with sugars and water. So in that first 14-day window, the number of cells that is going to be produced is limited by the availability of nutrition, in particular calcium. We have very high calcium requirements to form all of those cell membranes for adequate cell division. So in cherry production, our target is large fruit, and we need to get calcium, generous levels of calcium in early so that we get more cells, so that we get larger fruit. And then later, once we switch from cell division to cell expansion, we now have achieved high levels of calcium in the fruit, and now we want to switch to potassium to fill all of those cells with sugars, carbohydrates, and with water. One of the things that we're seeking to accomplish with cherries as well is to have very good fruit firmness. And firmness, if you have strong cell membranes from adequate calcium, firmness is simply a function of the turgor pressure within the cell, within the water pressure within the cell, which is directly correlated to potassium content. So what we did, if you look at this, we emphasized the manganese early. We cut out all the potassium applications before fruit fill because we do not want potassium, because during that cell division phase, potassium is going to prevent calcium from moving into the embryo. So we want potassium levels as low as possible before we get to the cell division or cell expansion stage. As soon as we get to cell expansion, now we can begin adding calcium, or begin adding potassium. So we also strongly emphasize manganese, because since manganese is the potassium regulator, even though some of these varieties and some of the trees that we were working with had very high levels of potassium already built up within the trunk and the branches and within the tree's frame, when the manganese levels moved up, they prevented the potassium from moving into the embryo in high enough concentrations to prevent calcium uptake and calcium translocation. So we end up with this management strategy, you end up with very strong fruit, very large fruit because you get a lot of cells, and very firm fruit because you have high turgor pressure from the calcium potassium. So understanding that shift and managing that shift is very important. And what I just got done talking about here is relevant irregardless of whether you're growing soybeans or corn or tomatoes or cherries. It doesn't matter. You have that cell division, cell expansion shift happening across the board on all crops. So that's a partial answer to the question about using SAP analysis to evaluate nutritional profiles throughout the growing season. The remainder of the answer is that we know that plants have different nutritional requirements based on different stages of physiological development, and SAP analysis can be used to very accurately chart demand curves. What is the demand for potassium on corn 75 days after planting, after the pollination period when you start filling grain, versus 10 to 14 days earlier? You can chart that very accurately, and what I particularly love about the technology, many years ago Charles Walters had a quote in which he said that only a few farmers have 30 years of experience. Most farmers have 1 year of experience 30 times. And using SAP analysis for us as a consulting company and for the farmers that we've worked with has been a very powerful management tool because it now gives us the opportunity to have 30 years of experience. By the time we have 1 year or 2 years of data where we're measuring consistently every 14 days throughout the growing season, we can chart exactly what that plant's nutritional requirements are for that specific variety and develop a nutritional profile of what we need to, how we need to manage that crop proactively in the future, which is very, very powerful. So what happened in cherry production? Well, we cut zinc applications. We eliminated them completely. In spite of that, leaf size remained the same. We have very large leaves. Fruit size actually increased. Fruit firmness increased. And most powerful of all, we got a significant increase in disease resistance to the point where there was, this last year, we had 2 different trials, one on a very disease powdery mildew resistant variety, which would have been Regina, one on a powdery mildew susceptible variety, which would have been Sweetheart, and both of them showed with no fungicide applications, we were not able to find any infectious levels of powdery mildew in either of those blocks of trees because we had much better trace mineral nutrition. So what we learned from this orchard, managing potassium and calcium antagonism is critical during the fruit development period. Again, manganese functions as a potassium regulator, and manganese and their traces are essential for disease resistance. So, benefits. We made these cherry operations a lot of money, which is very important for us as consultants. We have to deliver results. So if we look at what we have come as a company, and I'll try to wrap this up very quickly here because I know I'm running out of time. Benefits that we've realized as a company is, first of all, SAP analysis data, unlike tissue analysis data, corresponds with what we are observing in the field and what we're able to see in the field from visual deficiency symptoms. We're able to see that. Secondly, it corresponds perfectly with disease susceptibility. When we achieve plants that have better nutritional status on a SAP analysis, they have much greater levels of disease resistance, which is very important for us. As a consulting tool and as a sales tool, SAP analysis very quickly and very clearly demonstrates to any farmer's satisfaction whether a product is working or not. If you put on a magnesium product or a phosphorus product or whatever the case might be when you have deficiencies, those changes will show up on the SAP analysis quickly if the product is performing. It's a very powerful sales tool because it gives farmers confidence in the products that they're applying, and it also gives them a lot of confidence in the integrity and the honesty of the consultant that they're working with. So it has been a great reputation builder for us in the customers that we are working with and new customers that we're gaining as well. Most important of all for us as consultants and also for our farmers, this is something that we tend not to think about, but everyone gets to make 2 types of decisions. You can either make reactive decisions or you get to make proactive decisions. Most farmers make only a very limited amount of proactive decisions. They proactively decide what variety they're going to plant, what fertilizers they're going to apply before planting or at planting. But then for the remainder of the growing season, most decisions are based on reactant. They're reactive decisions, reacting to insect infestation, reacting to disease presence, reacting to nutrient imbalances, and it's a very disempowering process. SAP analysis has given us as consultants and our farmers the capacity to make proactive decisions and actually prevent problems before they ever get the opportunity to show up and become worse, which is, it's been incredibly empowering. Farmers love it, we love it, and it drives success and it drives making money. So in addition, farmers really appreciate the use of hard data to make management decisions, much more professional. It's no longer based on intuitive guesstimation. And a very important benefit that we've been able to realize as well is that we're actually able to customize and very accurately identify the nutritional requirements of specific cultivars. So take strawberry production. We've known for many years, decades in fact, top-level, top-tier strawberry producers customize the nutritional applications based on variety for optimum production. And we're now able to do that same thing very quickly with apples and cherries and corn and soybeans, because all the different cultivars do have slightly different nutritional requirements. And as we hone in onto those, we're able to gain additional percentage points in yield very relatively easily. It's been a very powerful tool for us from that perspective. We're also able to detect nutrient imbalances quite a long time before visual symptoms are first expressed. So it's much more sensitive than visual imbalances. From my perspective, if you see an imbalance showing up visually, you've already lost some potential yield. You've already had a negative impact on the crop. And again, proactive rather than reactive decisions, which is something that I feel very strongly about. And that's the overview. So we've had, Sap Analysis has been a tremendous sales driver and relationship builder for us as a company. Farmers are really empowered and excited to be able to see data about what is actually happening, and to be able to see the fluctuations, to be able to see the changes is quite exciting. And farmer engagement has gone up and success has gone up significantly because of having a much stronger tool and having a much better tool. So it's been very powerful for us. We love it. We're not going to stop using it anytime soon. And it's literally to the point where if farmers want to work with us and they want us to help manage their crops very intensely, we are approaching the point where we almost demand that they use Sap Analysis as a management tool. Otherwise, it's simply an exercise in frustration, because the tool is so powerful, we can get such powerful results with it that we do not want to even try to manage without it. So there's more that I could talk about, but I want to open it up to any questions that you might have and talk about the things that you want to talk about. You may be on mute, Michelle.
Yes, I just unmuted myself. Give me just a moment. One question is, can you clarify what you mean by cell expansion and the size? And when you do multiple production of products such as pepper, tomato, and different sizes of fruit?
Yes, great question. So when I'm talking about the cell expansion phase, is that take a tomato embryo. Tomato fruit at the 10 to 14 day mark will be about the size of a 22 caliber bullet or the size of a pencil eraser, depending on the variety. At that point, that fruit has all of the cells that it will have when it's mature. No new cells will be created. From that point forward, the only thing that is happening is that the cells that have already been developed and have already been created are simply going to expand and fill up with water and fill up with sugars and carbohydrates. So when I'm talking about the cell expansion phase, that's that point from that phase through to harvest is what we refer to as the cell expansion phase. So how do you manage this when you have multiple fruiting crops, or crops that are blossoming and pollinating and sizing at different times, where you might have tomatoes that are blooming and they already have fruit that is sizing as well. This is where the role of manganese and having generous levels of physiologically active manganese within the plant becomes critical, because the manganese now becomes the regulator for potassium and managing that calcium-potassium antagonism. So having generous levels of manganese on these multiple fruiting crops is absolutely crucial, and we have found that to be a very effective management strategy for managing those interactions. So that's where we focus our energy.
Another question, how do we interpret SAP analysis, meaning how do we identify deficiencies or surpluses of nutrients for crops when thresholds have not been established? Can you share how your team does that?
Yes. So trying to think of how to describe this simply. We have learned some new things just recently which impact this slightly. So first, the simplest piece and the easiest piece is the highly mobile elements, which are NPK and magnesium, nitrogen, phosphorus, potassium, and magnesium. When we run SAP analysis sets, obviously we're analyzing new growth and old leaves. And so this is what I refer to as differential testing. So when you have differential testing where you're measuring old and new, the plant will do everything that it possibly can to maintain ideal levels of nutrients in the new growth, which is why the new growth for most diseases, there's a few exceptions to the rule, but for many diseases, the new growth will remain healthy the longest because it has the closest to optimum nutritional balance. So whenever you have any of these four highly mobile elements, the deficiencies will show up on the old leaves first, which is a fundamental flaw in tissue analysis. When you measure just the old leaf or just the new leaves at the top part of the plant or at the tips of the growing shoots, the last fully mature leaf, you will never see nitrogen and phosphorus and potassium and magnesium deficiencies until it's way, way too late to have a significant impact. Those deficiencies show up first on the lowest and oldest plants, or oldest leaves. So if we want to determine whether there are imbalances, we look at the ratios of these mobile elements between new leaves and old leaves. And whenever we have higher levels in the new leaves than we have in the old leaves, you can generally say that that plant is deficient. So for example, let's say we have peaches. We have 3,000 parts per million potassium in the new growth at the tip of the growing shoots, and we have 2,000 parts per million potassium in the old growth. That to me is an automatic indicator that that plant is running deficient in potassium because it is drawing potassium out of the lower older leaves and moving it up to the new growth. It is sacrificing the old leaves to keep the new growth healthy. And so you can do that exact same thing for all of the elements. And usual rule of thumb is whenever you have greater than a 10% spread, you have quite a pronounced deficiency showing up. So if you have 2,000 parts per million on the new, that would be if you have less than 1,800 or 200 less on the old. So whenever you have a greater than 10% spread, you can use that as an indicator of a deficiency. Unless, and this is a caveat, this is still relatively new information. I'm almost hesitant to talk about it a little bit, but it's worth putting out there in case it can help someone. Unless a nutrient is so startlingly low that it is actually limiting plant growth, sometimes you have less than 10% of variation, but everything is so low that it's limiting plant growth and it's showing up as if though it were adequate. So let's take nitrogen, for example. We've observed nitrogen levels on some strawberry fields where we've had 300 parts per million in the new growth and 280 parts per million in the old growth, which is a very narrow range. And you would think that based on that, it's not showing up as a deficiency, with the exception of the fact that we know that strawberries need to be in the neighborhood of a minimum of 800 to 900 parts per million. And the levels are so low that they're actually limiting plant growth. And since they're limiting plant growth, the deficiencies do not show up, the range does not show up between the old and the new growth as it could potentially. So That's a partial answer to the question. The reality is that there are some general guidelines for different types of crops: grains, small grains, broadleaf, broadacre crops, tree fruits, and vegetable crops, that it would be possible for us to put together some general guidelines of approximately where a crop should be, just purely based on the ratios. So we know that there are certain ratios of different trace minerals that are needed for vegetative crops, such as lettuce and cabbage and salad greens, versus reproductive crops such as tomatoes and soybeans will have slightly different ratios of some of the trace minerals. So those are things, that's information that we have developed just as experience, in our experience at Advancing Eco-Agriculture, and something that we've not yet done, we just haven't gotten the bandwidth to accomplishing it, is actually putting that together in a template or an outline for a variety of different crops, but we would be able to do that, and perhaps that's something we need to make available.
Thank you, John. There are some highly technical questions that are coming in, and with your permission, I'd like to table those and send those to you so that you can provide an answer in writing and that we can circulate to all of the attendees following the webinar. I just want to make sure that we get through as many questions as possible, but there are some that require some highly technical, maybe even some references to data sets. Is that all right with you, John?
I'd be happy to do that, absolutely.
Okay, excellent. Give me just a moment to pull up the next question here. And John, can you share any interest in developing nutritional requirements on grapes?
I don't have access to the data that Crop Health Labs has on grape growers outside of Advancing Eco-Agriculture. Interestingly enough, we've done work on a lot of different crops, but we have just recently begun doing a lot more work on grapes, both table grapes and wine grapes, primarily on the West Coast. So I don't really have enough data at this point that I'm able to just off the top of my head give you a good answer to that question, but I'd be happy to respond to that in writing as well.
Okay, wonderful. We have one question here. Are you measuring the Brix of leaf sap? If you could, John, detail the difference between Brix and the sugar that is reported on the Sap analysis test for our listeners.
Perfect. So Crop Health Laboratories and Nova Crop Control measures the actual sugar content itself within the plant sap, which is a different number from the Brix number. So it is an actual measured sugar number, and basically can be used in the same way, much the same way that a Brix number can, but it doesn't have the variability and the fluctuation. It's not susceptible to the fluctuation that a Brix number is susceptible to based on dehydration or time of day and so forth. So it's a much more consistent number.
Thank you. Give me just a moment to pull up a question here. Is there a reference for optimal sap levels for nutrients for many different crops?
So the laboratory in the Netherlands currently has data that they have run on over 200 different crops. With that being said, we do not grow tulips and gladiolus on a commercial basis in the United States. So of those 200 crops, there are actually a number of crops that we grow commercially here in the United States that they do not have reference data sets for, that we are currently in the process of developing. With that being said, with some experience in using SAP analysis, I personally, as a consultant, and also within Advancing Eco-Agriculture and our consulting group that we have, we are very comfortable making recommendations without having established parameters, purely based on looking at nutrient ratios and also looking at the variability in the differential testing between new and old leaves. So it's very possible to, with the limit of, it does not take extensive experience. I'm comfortable with as few as 10 sets of data. If I have 10 sample sets, and I've done it with less, but I can begin working with a brand new crop that I have zero prior experience or history with, and I'm comfortable making recommendations with as little as 10 data points or 10 data sets based on looking at nutrient ratios. And I believe that's something that any agronomist who has some familiarity with nutrient interactions and plant physiology and nutritional requirements at different growth stages will be very comfortable putting together very quickly when they become familiar with how the data is presented.
Thank you, John. We have a question, a very appropriate question from one of our growers in California. What applications, if any, that you know of, are there for SAP results on aluminum? Could you detail your company's experience with that?
In short, well, aluminum is obviously not considered a nutrient, but if anything, more of an anti-nutrient. So there's two pieces. One is we often see higher aluminum levels showing up where we have more toxic soil environments, particularly where we have very poor microbial systems. So that is the one area that we see high aluminum levels showing up that we become somewhat concerned with them. The primary concern with high aluminum showing up is that it tends to tie up and bind other elements, particularly phosphorus. And for whatever reason, I have not been able to find any, and I haven't looked that in depth. I have not been able to find any documentation or any references for aluminum binding other trace minerals and trace metals. Yet, based on field observation and experience, whenever we have high aluminum levels, the functionality, the physiological functionality of manganese and zinc and iron and copper seems to go down. That's just a field observation, something that I've observed. Lastly, if I'm not mistaken, and Michelle, correct me if I'm speaking out of line here, but I believe that on occasion we have seen leaf samples degrade in transport when we have 105 plus degree temperatures and they're not packed properly and cooled properly. And whenever the leaf samples degrade in transport, we see two markers. We see ammonia levels spike and we see aluminum levels spike. So we have seen those, I've had those two observations. Is that correct, Michelle?
I would say so.
Yep.
Very good. John, you made some references to nutrient ratios. Can you briefly detail some of the more important ratios that would be applicable to, say, strawberries or small fruit crops?
Oh boy. My biggest challenge is I do all of this every day so rapidly that I tend to not even consciously think about it. So I think the best answer that I can give to that question is that we actually need to document the ratios that we look for, and circulate that in a written form to all the attendees. And I'd be happy to put that together, but I don't know that I can give a good verbal answer just off the top of my head. I know what I'm looking for, but there's too many different ratios. I don't think it justifies talking about it right at the moment.
Understood. And for those of you who have future questions, if you have specific questions about specific nutrients, please be sure to detail what crop you are looking for an answer. And we'll be happy to either provide that online here or definitely follow up after the webinar. John, do you have any experience in correlating sap analysis and hormone levels in plants?
Very interesting question. Partially, yes. So just in brief, all right, so first of all, let me say that in our consulting work, we do not have a history of running hormone analysis in a laboratory. We are simply using field observation of root development, fruit development, bud development, and shoot development to gauge hormone balances within the plant. So we do not necessarily have lab data for that component. We do, however, manage nutrients and manage nutrient applications to shift hormone balances, or rather, I guess I could say shift hormone imbalances within the plant. And I tend to lump things together in two broad categories. The first being essentially being male versus female, reproductive versus vegetative, cytokinin versus auxin, and kind of manage those two primary functional groups from that perspective. So just very briefly, there are three elements in particular that give a plant a very strong reproductive response, and those are manganese and phosphorus in particular. And then there is a third element which we do not have the data for on the SAP analysis, but which we use quite a bit in our consulting work, and that is cobalt. Cobalt in growing root tips greatly increases the production of cytokinins and helps maintain root dominance and increase reproduction. So we work with those three elements in particular to try to maintain root dominance and cytokinin dominance. So those are the things that we look at from a mineral nutrition perspective. Then we also work with tools, obviously, such as high-quality seaweed extracts to maintain cytokinin dominance as well.
Excellent. Thank you, John. Those are the questions that we have for right now that would be beneficial for the entire audience. And I'm going to draft a brief response and have John answer specifically some of the more technical questions in a follow-up email to everyone. So John, if you have more content, I'll turn it over to you to proceed.
No, this is all that I have. I'd be happy to, if there's any additional questions. I'm not sure where we are on the hour, but I'd be happy to answer additional questions if appropriate, or respond later, however you determine is the best path forward.
All right, thank you, John. We appreciate everyone's time this evening, and again, if you have questions that you want to have answered prior to our adjourning, go ahead and send those now if you think they would benefit the entire group. Otherwise, there are some highly technical questions that, again, we're going to answer offline and send a very detailed follow-up to all of the participants this evening. Crop Health Labs welcomes any additional questions, and you can reach us directly. My email is there, michelle@crophealthlabs.com, and we have a team of SAP analysis advisors that have been trained by Advancing Eco Agriculture. They've been trained by the laboratory in the Netherlands, and also some of our consultants are the laboratory staff themselves, answering some of the production and recommendation questions for our clients. In your follow-up email, you're also going to receive an exclusive offer for SAP analysis. There's a coupon that you'll be receiving in your emails, so definitely keep an eye out for that. And if you have any additional questions or comments about the technology, we're happy to entertain those. Just give us a call or email directly. You can also drop inquiries and find out more about the SAP analysis technology on our website.
Thank you, everyone. Hope that you enjoyed it as much as I did, and I look forward to being in touch.
Right. Thanks again, John.
Thanks, Michelle.
Good
Talk
evening.
to you soon. Good evening. Bye.